Good morning, everybody. Welcome to this workshop today. I'm glad to see so many happy, smiling faces here. I know that some quick apologies are due because a couple of our colleagues are stuck in traffic on their way out from Abu Dhabi. Apparently there's been a very bad accident, and so they'll likely to turn up a little bit late, but I'm sure we'll welcome them along as well. The subject that we're going to be dealing with today, I believe, is not only with Tuta absoluta, which you can see on the board here, but we're also going to be dealing a little bit with some of the problems that we have with date palms as well. And these are, to be honest, two very serious problems that we face here in UAE. And it's very timely that Dr. Shahir is here to talk to us today, because we need to find some long-term solutions to these problems. For a long time, all we've done is use chemicals to spray the trees, and the result has been that we've seen increasing numbers of pests. Okay, now we cannot continue to keep spraying more and more chemicals. People here want safe food, they want healthy food. It's our task to try and to encourage the farmers to provide that health, safe food. To do that, we need a structure and a process by which we can advise the farmers about safer ways to produce the food which is eaten by the consumers here. And one of the most advanced technologies which is coming along are all the biopesticides, all the microorganisms, all the natural predators which can be used to control the main pests and diseases which we find around the world. And it's very timely that Dr. Shahir has come along to talk to us about these problems, because we are in desperate need here in the UAE of solutions to not only the Tuta absoluta problem with the tomatoes and the greenhouse crops, field vegetables, but also the date palm weevil and all of those problems with the dates. So, you haven't come here today to hear me talking about our problems. You've come here today to hear some solutions. So I would like to hand over to Dr. Shahir, say welcome to him, and I'm sure that we will all be paying attention and listening, because we will have a test later to see if you've all been asleep or if you're awake. I'm joking. Thank you very much.
Thank you very much.
The rest of the day is yours.
Assalamu alaikum and good morning. Follow up from your introduction, I have a small disappointment for you. My task today is not to provide you with answers, but to more challenges to take home to help solving this problem. My name is Shakir Al-Zaidi. I'm the Managing Director of Russell IPM in the UK. We are a small company, but we are big in ideas, and we lead the field of pheromone applications in pest management. We work very hard to develop new solutions, new approaches, and for that the company has been awarded for 2 years the Queen's Award for Enterprise, 1 year for its innovation and the other one in the international trade category. The first talk today is about Tuta absoluta. Tuta absoluta is an insect I adopted back in 2009, where the problem was expanding in Europe and crossed to North Africa, and nobody cares about it. Well, I took it as a personal mission to teach people about it and follow it and share the information and experience about Tuta throughout. The biggest problem which has really attracted me to this insect is the speed at which it can attack the countries, particularly if the environment was correct. This is the picture from Morocco, 2008, when in the north of Morocco, the fields were completely decimated. And guess what? All the experts in the country haven't got a clue what is happening. The farmers asking for help from the ministry, and the extension workers go there, and they are just as baffled as he is. And that particular attack kept going, moving from Morocco, of course, to Algiers, from Algiers to Tunisia, to Libya, El Mafraq in Jordan, that's in Greece. The attack was continuous and relentless. And in most cases, people don't know what's going on. That's one problem. The second problem, which is the biggest, the legal structure of pest management or crop protection in most countries is very strict and very stuck in the Middle Ages. For example, in one country, the quarantine officer wanted to check whether this pest is coming to his country or not. Legally, he could not import the pheromone because legally this insect has not been registered in that country, therefore he cannot import it. And this person was basically empowered by the minister himself to do this job, and yet he couldn't do it. What did he do? He asked his son to write to me to send him in 20 pheromones, smuggle it in a private bag to the country so he could use it to manage, so he does not break the laws of that country. When the insect reached the shores of the other country, the head of planter production of that area, he was so scared to advise the capital, he asked the engineer, please, could you take the samples and tell them what you found, because otherwise they might fire me. They think I brought that disaster to the country. That type of mentality being faced and gave Tuta absoluta the chance to move freely throughout all these countries. By the way, this is examples of aubergine, Badinjan, in Crete. In Greece, there's a different problem was there. It was the academics got stuck in academic debate. Is this insect Tuta absoluta or is this Phthormia opiquilella? Who the hell is interested? The farms are burning, the farmers are losing their money, and the academics are fighting which one is this? Is it the Phthormia or is it the Tuta absoluta? Eventually, we sold it for them. We gave them 2 traps, one for Phthormia and one for Tuta. Put them in the field and see where the insect will go, this trap or that trap. And then everybody got shut up. And the insect being declared in the country, and they start to deal with it. These are some examples will be very useful for you to look at it. And particularly if you look at here, the damage here. This is the typical damage you get. By the way, this is what you need to look at, even if when you have an imported tomato into the country. Because in most cases, the insect will lay the eggs under the this, we call the crown, underneath it. And then it will break into the tomato and build before anybody can notice it. So the United States have declared as a rule, any tomato comes to the country, it shouldn't have that crown on it, so that the inspector can easily check if there is any pierce on the tomato or not. This is another, that's the way it becomes very advanced. And when you get to the damage to that level, it's too late to do anything anyway. We'll talk about it later on. The more serious thing for me is the insect in Sudan have moved to potato. And that is also the case in Ethiopia, because in the Blue Nile area, there's an encouragement to increase the production of potato in these areas as a staple food, as a carbohydrate food source. And it's moving to the potato. When the season of the tomato finishes, it moves to the potato. It's also moved to the aubergine, the badinjan. And most of you know, aubergine in many countries are very important vegetables. Between tomato and aubergine, the families have of their diet, how the weekly diet is cooking aubergine and tomatoes. Just a little history. The actual insect came from here, from Colombia. And it was happily living there, balanced with natural enemies and everything for millions of years. Doesn't bother anybody and nobody bother her. Until we clever people start to pump in pesticide by the tons in Latin America to increase food production. We broke the balance between the insect and the natural enemy, and it, within a few years, dominated the whole of South America. In Brazil today, there is a law prohibit farmers from growing tomato in any land below 1,000 meters over sea level. Bingo, this is it. You cannot do it. Because the number of generations is so continuous that it's impossible you could control it. They spray cocktails of the most lethal insecticide, and still they can't control it. So the only way to do it is they stop people from growing tomatoes on the shore side, and they only allow it to grow on a higher level where there is a break in the weather. There's a winter and there's a summer, whereby you could have a bit of a break in the life cycle. Back in 2006, there's a very keen Spanish farmer from Tarragon. He's got a greenhouse, and he went to Latin America and he found this lovely variety of tomato. And he wanted to grow it in Spain. So he took a small seedling, put it in tissue, Kleenex, moistened it, put it in his pocket, and he brought it with him. And guess what? It was full of Tuta absoluta. He put it in his glass house, cultivated, and moved to another glass house, and started to move. The insects started to move from this area to all the coastal area, all the greenhouses on the coastal area, north and south. So a year later, 2 years later, there's a study, climatic study, being studied. All these points are the climate profile of this area. It's being studied compared to the typical climate profile which Tuta absoluta prefers. And what they found, all these green points are being discovered as the weather is fantastic, ideal for this insect, not to grow, but actually to settle. So that is the conclusion being reached. Some of you might ask why the discussion only in this part, because this is a study was sponsored by the European Union, so they are only interested in the European territory to study it. If we are interested, we need to pay for it. So that is what happened, and that's what been expected, but as you know, the insect moved beyond this area. So in a few years, from Tarragon, moved to the rest of Spain, to Morocco, because of the close agricultural relationship between Morocco and Spain, moved to Morocco, moved to Algiers, and then from Spain, gone to Italy and Spain. Of course, moved up to the north. We have it in England now, in Yorkshire, believe it or not. Tuta absoluta, we have it. We have it in Sweden, we have it in Switzerland. And these green spots are actually countries where they imported tomato, and they found it in the quarantine services, and eventually moved to the markets, but still has got a limited presence in these countries. The more serious ones is Italy. Italy is a very active agricultural exporter in the Middle East and North Africa. and Southern Europe, because they don't sell the seeds. But what they do, they sell the seedling. They grow the seedling and they sell it to the farmer directly. And with that, they were sending all the eggs and larvae of the Tuta absoluta. They were selling it to Tunisia, to Libya, to Greece, and even to Turkey. So Italy was a very major country to export Tuta throughout. And then, of course, from Turkey went to Iraq and Iran, and you have from Syria and Jordan came to Saudi and to the Emirates because of the export of the tomato, and moved on. Now it is in Ethiopia, but also it is in Senegal on the other side, and it is in Iran all the way to the south of Iran, and of course all the Gulf states, it's there. Qatar, Kuwait, UAE, Oman, and Saudi Arabia, of course, and Yemen. This journey took between practically 2007 to 2010. It was in 3-4 years, covered the whole territory. That is very fast, unusually fast. And if you compare it to any other pest moved into the area, this is the fastest moving pest. And one could wonder, why is that? The answer is we. We are very active in trading. Because the problem is, if you have a tomato with a larvae of Tuta absoluta, and you export that tomato, the larvae will be transported to that country. So it is not just by the natural movement, by wind and by the normal ways, no, but by the actual human activity. The export of the seedlings and the export of the tomatoes. Plus, there is another practice, which I'm not sure whether it exists in the Abu Dhabi, and that's if you have a cooperative, they share the boxes which they collect the tomatoes from the greenhouses and they take it to the packing house or take it to the market and bring it back again. These boxes became the conduit to transfer the infestation between farms, because any box has got an infested tomato. The larvae could be stuck in one of the corners and move to the other greenhouse and take it. So that way, it moved very, very fast and very efficiently, and thank you to the dynamic human activity. Where we go from there? Well, I think it's definitely moving that direction, and most likely it's going to move in that direction. There is indication it is in Afghanistan, but there's no exact report. And of course, the information very scarce in the Central Asia, but the Pakistani authorities have got waiting to look in the lookout, and also the Indian authorities are watching it in the northern part of India. I expected it will move gradually all the way to China, and China is the largest tomato producer in the world. And that could cause some economic damage to the tomato market, and particularly the industrial tomato market. So in summary, that is the mean of transfer of tomato of Tuta absoluta. Through importing infested tomato, infested seedlings, the boxes, as well as the truckers. The trucks are a very important way of doing it, because most of these drivers, they cook themselves, they eat, they shop from one country and they take it with them, and they stop and they cook and eat and they move on. So this is a process, and then sometimes they sit in the border area for a day or two until they clear it. So they, being over that period, as a good way of passing the tuta from one country to the other. Where do we go from here? It's a serious problem. It affected the livelihood of a lot of farmers, and also it did have political consequences in many countries where farmers lost their livelihood. So we are talking about some serious issue here. Now, what is the main problems we have? We as a plant protection or plant health officials, what is our problem? The main problem we have is the weather in our areas here, at least in the Middle East, from the Mediterranean all the way to Yemen, let's take that area. The weather could fluctuate. You could have some very wet winters, you could have some dry winters. You have cold, you have moderates. So what happened? The insect will go in up and down. One day, everybody is up and arm to fight Tuta. Next year, they don't find it very serious. So they think it's gone. Third year, maybe definitely gone. And the fourth year, when everybody's sleeping around, boom, it hit them again. So that is one of the major challenges we have, is the fluctuation. It's a new pest. People haven't got used to the way it reacts. And of course, the weather fluctuation, it doesn't help. People go into false sense of security very easily, very quickly, and cause big problem. The other problem we have is a market fluctuation. Because farmers use pesticide when the tomato is worth something to them. But half the way through the season, if the market becomes too low, and collecting the tomato and taking to the market is more expensive than actually what they are getting back from it, what they do? They just abandon the field. And when they abandon it, they leave it as a fertile ground for Tuta absoluta to grow and to multiply. The other problem maybe doesn't exist in this country, but it's certainly in other countries, because tomato affecting the livelihood of the poorer side of the society, it's becoming political football. Opposition use it up to attack the inefficiency and incapability of the government bodies to handle it, and the government attacking the opposition, they consider it as a way of inflaming the political situation in the country unfoundedly, and then the poor farmers get lost in the middle. I know a few countries whereby that problem, it was caused a serious problem. Even to the plant health professionals could not handle the problem properly simply because of the political hot ground. So that is another lesson we have learned in the last few years about this particular pest. The way I look at it is we need to empower the farmer. Having the knowledge only in the hands of the officials and the experts and the engineers and the extension is not the real answer. The real answer is the farmer needs to be the expert, because he's the one who's going to the farm every day, and he's the one who can pick up the fluctuation in the population from one day to the other. The second thing, of course, within that structure, you have the education. We need to educate the educators. We need to educate the agricultural students, the extension workers, to educate the farmers themselves. And the final point is integration. It is not only one person's or one body's problem, it is everybody's problem. So we need to integrate the efforts, whether it was Ministry of Agriculture, or whether it was a Society for Support of Farmers, or it was non-governmental organizations. Anybody active in that piece of ground, their responsibility to integrate that activity, to empower the farmer, to educate him, to give them the ability to fight that particular problem. This is a very important issue. We faced it in different countries. I said to you earlier, this issue, I adopted it back in 2008, and I moved on to monitor and to help and educate about Tuta absoluta throughout the area, because of the problem was causing and the lack of knowledge. So what happened, what I noticed, there is a bit of a discord. There's a lack of national objectives. It was basically people saying, well, you have a problem, we have pesticides. Go to the shop and spray it. If one didn't work, use the second. If that didn't work, we'll mix 1 and 2 and we'll come up with something will definitely work. And people like this. I remember I went to Crete to a farm to check about it in 2009. And here I found this agricultural engineer who was very proud of himself, to say, I discovered a blend which can control the Tuta absoluta for 7 days. I said, what are you using? He said, a mixture of 4 insecticides. Mixture of 4 insecticides, including dimethoate, including methamine, including God knows what, mixture, and can stop it for. And he was very proud of himself. And the farmers, they say, thank you very much, you saved our skin because of that. But hang on, you saved his skin. But what about the consumer who's going to eat these tomatoes? What he's going to eat? You're going to increase in this method, you increase the resistance. And every time you increase the resistance, you increase more insecticide, you make more blend, and then the poor consumer will eat all these insecticide in his food. So really we need to have a guidelines, a structure. When you want to control, it is okay, you want to control the problem, but make sure whatever policy you do, whatever structure you do not create or increase the incidence of insecticide resistance. And at the same time, make sure we don't end up with tomato full of cocktails of harmful insecticides. If we reach that balance, then we are successful. How to reach this one? It's not the easiest thing. For a variety of reasons. One of them is, unfortunately, we have the private sector competition because it is old style. You're a salesman, this is your livelihood. Your boss have imported 5 tons of this material and your target this year is to sell them. Go and sell them. Even if they mean you sell them to the same farmer to use it again and again and again. And we've seen that happen in different countries. Some insecticide actually being demolished in 1 year. When I say demolished, they became ineffective. To the point that the company who produced it stopped exporting it to that country. They said, we're not going to export to you that insecticide for a year to give the insect the chance to become more susceptible to it. Otherwise, it will be a disaster. So let's look at it here in a very quick way. If we want to do some strategy here, what do we need? It's not a rocket science. It's been known, we've been talking about it for years, about different insects. So it will work here if we work on it properly and strictly. The first thing, the farmer needs to learn how to prevent the problem. And preventing it is not a difficult thing. There are specific things he has to do. When you finish a season, you have a lot of pupae in the soil. You don't use that soil. You don't use the old dead plant as a compost unless you compost it properly to make sure all the living organism will be dead there. Whatever import, whatever you bring in to the farm, you have to make sure it has got no pupae being brought in from the previous growth cycle. Secondly, if you have any damaged goods, any damaged tomatoes, any damaged plants, when you don't like them, you don't throw them outside the farm because the insects will come back again. So you need to quarantine that, plastic bags, burn them, whatever would you do them. So there is a lot of hygiene and cultural development it needs to be done in the farm. The insect, they love the environment closer to the soil. because it's like an air condition for them. If the weather's too hot, that becomes nice and cool. If it's too cold, it becomes warm. So for them there. So they need to really learn how to raise the tomato off the ground, even by 1 foot, 2 feet. Just allow some air to move between them to stop the development of this microclimate under the branches to allow the tuta to grow nicely and quietly. The other thing, which is the detection. Farmers need to detect using pheromone traps. So here, remember, the pheromone traps I'm talking about is to help the farmer to detect the level of the population in his field, to help him a decision-making tool to actually intervene. This isn't here, I'm not talking about it as a tool to control. This is a tool to monitor. One trap every hectare is more than enough to give the farmer an idea what is going on in his farm. But also he needs to check physically and to tell him, to give him the simple tool how to compare the tunnels and to decide when to intervene. And then of course you have the intervention, which is basically either pheromone mass trapping, attract and kill, or insecticide of whatever level we're talking about. So all that, if you look at it, it goes around the farmer. And you as an organization, really, that type of strategy, it can be a key to what you're doing. And if you could really educate the farmer to apply this cycle, 70% of the problem will be managed, even before you get to the use of insecticide. You could manage it. So basically, we're talking about to contain the damage, you need really early detection. You need to make sure you know what's going on. You need to understand the insect behavior, and this I'll come to it in a minute. And basically, and that's a very important point, is to treat all life cycles. What happened with most insects, we know them, they have peaks, like 2 generations, 1 generation, 3 generations. With Tuta absoluta, because of the short life cycle it has got, you end up after 2 or 3 generations, you have an overlap in generations. So you go to the greenhouse and you find all live generations at the same time. So if you are going to treat one life cycle, one part of the life cycle, the other life cycle parts will keep going on, and the farmer keep panicking. He sprayed, and his next day nothing happened. Well, actually, it's not that true. It happened to that particular stage, but the others took over and continued. So unless you know what's going on, you know which life stage is the prominent, it will be very difficult for you to actually manage the issue. And of course, the biggest problem is complacency. If you don't take the issue seriously, it will eat you up. This is a very simple example of monitoring exercise we did in Turkey, in the Antalya area. I wanted to have this one just to demonstrate one point. These are different traps and this is in Andalusia and Zafraya in Spain. What you have here, this dark graph, is the average between various fields. But also what we did, we monitored the temperature of the field at the same time. What you notice, the profile of the temperature graph is almost identical to the population graph, which means the level of population responds very quickly to the fluctuation in temperatures. Here is the key. If you have an area whereby temperature could fluctuate overnight, within a few days, the explosion in population and damage could be very high. And that's why the farmer needs to be on guard all the time, every time, in his farm to make sure when something like this happened, he's ready and he is to intervene. rather than waiting for something to happen. I mentioned earlier on that you could have more than one part of the life generation in the field. So if we look at all this, we need to think about the management mix. You need to think not by brand name, think about which life cycle, which part of the life cycle you need to treat. And ideally, you need to look at all of them. I don't mean you mix them in the same bottle, but you need to look at all these issues and treat them accordingly. And there are many solutions in the market, whether it is from Russell or the other 99 companies in the world. There are solutions. The issue is how to select them and how to correctly put them together in what we call a management mix as a program to handle all these life stages in a very comprehensive way. If you monitor Tuta absoluta very well, and we could see that in many countries now, we advise people, don't use your heavy guns from day one, for heaven's sake. You could use simple solutions from the beginning, and that is like repellents. Repellents are very effective to repel the Tuta absoluta from coming to the plant and lay eggs. That's the first line of defense. Something like neem oil is a natural material. It is harmless and cheap. If you spray the plants at the early stages, even once every 2 weeks, it will give you the defense you need. It will repel them, it will stop them from laying the eggs on the plant, but also it will give you repellents against whitefly. So it's two targets at the same time. And we found some formulations of neem oil also can give you a fungicidal activity, so to prevent fungal growth as well. So a cheap, simple, natural product could save you a lot of trouble if you use it at the very beginning, right from the beginning of the growing cycle. That is basically targeting the eggs. When the problems start to arrive on the leaves, here we need some larvicide, but here is the issue. The insect stays a little bit, although the eggs are laid on the leaf. When the egg hatches, the larvae will walk on the leaf to the edge and enter it from the side and start building the chamber. So you have a small window of opportunity to hit it with simple, natural, harmless insecticide, which is the Bacillus thuringiensis, BT. The use of BT is very important for a simple reason. It's a very specific insecticide. It attacks the Lepidopteras, حرشفية الأجنحة, which means the natural enemies, if they have managed to exist, they can't live. So they can selectively save the natural enemies, which later are going to help you to control the Tuta absoluta, but only it will target the Tuta absoluta itself. But once the insect gets inside the leaf, the BT will not be effective, because they will be eating from inside and the BT will be on the leaf, and normally it will not survive more than 24 hours anyway. So you have to move to the second layer, and that is to look for a larvicide, but not any larvicide. That is the key. You need a translaminate larvicide, a larvicide which can penetrate the first skin or the first layer of cells in the leaf. Please don't mistake that with systemic. I'm not saying systemic. Systemic is dangerous because you are sending the pesticide through the sap all the way to the tomato inside it. We don't want that. We're talking about the translaminate, which is basically an insecticide. When you spray it, it stays in the leaf. doesn't leave the leaf, doesn't go into the sap, stays there. And there are a few of them, and they're very successful. But you have to use them carefully and not to use them excessively. Most of these larvicides, technically, if you read the instructions of the manufacturers, finally, not the translated label by the local distributor, by the original label, you will find they says, do not use it more than 3 times per season. Because otherwise, resistance will develop as well. So for the sake of keeping that insecticide for yourself, circulate. When you use a successful insecticide, don't kill it. Use something else, something else, something else, so that you could have these, your flexibility all the time to use these insecticides rather than using them. And the same thing talks about the larvae and the pupae, and there are examples that there are some microbials, if you spray them in the soil, can help you to actually damage the pupae in the soil. So if you look at this mix and plan your strategy around it with whatever available insecticide in the market, you can get into the objective which you want. We did some trials in Jordan. This is not my work, but Dr. Marwan. I think he presented this in the last seminar. Some of you were present in Amman. And he compared 7 insecticides from the market. Most of them, some of them are actually chemical, and some of them are biologicals. And to be absolutely honest, when you look at the performance of all of them, are not bad. In open field, apart from the azadirachtin, which gave 73%, the rest is all over 80%. So really, there is no reason why we should underestimate the role of the biological or the botanical or the microbial insecticide when you compare it to the synthetic insecticide. Yes, sir? Yes, actually. The coragine is a translaminate. The BT, it is not, but if you use certain amount of spreaders, they can help you to penetrate as well. Antario is a formulation which we developed, which has got a BT, but also it has got abamectin. So between them, there's a synergistic effect, but also there's a translaminate effect. Radiant is doing translaminate. Biotrine is translaminated. Proclaim is amamectin, benzoate, which we know is a translaminate as well. And so is the azadirachtin. So all of them are, apart from BT, they have a translaminate purposes to some degree or another. Now, this is a very important slide, please. The way I could classify the damage for Tuta absoluta at 3 stages. This is the most important stage, the early stage, where you go to the farm, the traps are full of Tuta absoluta, but actually you can't see any damage. That's when the insects are building up its population. They are living on the lower end of the bottom end of the leaves, the one which are very weak, nearly dying, and you don't tend to look at them. They are developing over there. When they get to a certain critical mass, then you start to see the damage. So that is the area, that is the time of perfect intervention. And that's when you could use repellent, like neem oil, for example. You could even use, if you want, BT. But also there's something very important. People use it every day, sulfur. Most of the growers in greenhouses, they use sulfur as a fungicide. That is a fantastic repellent to Tuta absoluta. So there's no reason why these type of products can delay the emergence of Tuta absoluta quite a while. In fact, most of the season, actually, you could be free of Tuta absoluta if you just carried on with this one, with this particular mix, until you start to see damage on the leaves. That's the medium side, the medium level, and that's when you start to use the translaminate. But if you start to use the translaminate from that stage, you might lose its activity when you need it. So try to save it until you start to get here, and then you start to use the translaminate larvicides. If you go to the field and you have a damage of that nature, don't waste your money on pesticide. Just collect the tomato, put it in a plastic bag, and burn them. That's it. Some tomatoes you might, if they have like a 2 or 3 times where they could produce tomato, okay, collect all the tomatoes, put them in bags, let them to compost in the sun, but close them very well, and fertilize, and hopefully that next push you will get a healthier tomato. But otherwise, don't waste your time and don't waste your money. So the key is to go back from this stage or this stage. Keep the damage within that. And something I must say, if you look at deal with the problem at this way, you are going to treat other insects at the same time using this strategy. If you use this strategy, whitefly will be controlled at the same time. Leaf miners will be controlled at the same time. So you don't need to use other insecticide. Just the same mix will handle the rest of the problem. So I think we managed to talk about this, but now this is just a way to summarize it. We need to, as much as possible, delay the development of the resistance, and basically we try to be careful what to say to the farmer, because we can advise him to use expensive insecticide, but maybe he can't afford them. So we have to be careful and to use an affordable mixture of insecticide whereby he can practically use them. And this is a very important issue, and many countries actually adopted this idea. You know, most countries, if not all countries, they have a strict registration, pesticide registration. And they have a very strict label adherence. This pesticide being registered on this pest, or this pesticide registered on this crop. Very strict, which is fine, that's a good thing to do. But when there's a problem comes in, people need to be a bit more pragmatic, much more practical, because procedures could take time, and time means damage. So many countries, I know, what they did when the Tuta entered the country and they don't have a label to say you could use for Tuta absoluta, they invited all the pesticide companies, sat them on the table, guys, what have you got for Tuta absoluta? I got something. Okay, you have a registration? Yes. Make an application now. Write a letter to say, I want to extend my label to Tuta absoluta. And they took all these applications and they gave them provisional approval for 6 months only to extend the label to Tuta absoluta while you are preparing your data and your file. So they don't open the door randomly. They gave it just a window to give them a chance to put these applications properly. So within 6 months, if you haven't put any application, your approval will be canceled. This is it. We gave you 6 months. So many of these countries, this type of relaxation, it helped them. Sometimes in some countries, pesticide company came and said, look, we did an experiment in that country. By doing this formulation, it worked. Okay, bring it in. I'll give you 1 year approval, but within that year you have to give me all the evidence to support registration. Get in. So that way, there was a positive, for the first time, there was a positive interface between authorities and between pesticide companies to actually cooperate to handle this problem timely, but without getting over the law or ignoring it completely. The other issue which came out with Tuta absoluta, which is thankfully, is people were looking for creative ideas, new solutions, in order to help them to solve the problem. For the first time, people start to use pheromones in a large way. If I say to you, over the last 7 years, in the Mediterranean region, there's over 8 million pheromone dispensers being sold for Tuta absoluta. I wouldn't believe it myself if somebody told me that. Because in the 20 years of my company, we haven't sold 1 million dispensers for the whole different type of insects. And within that only range, one insect dominates the market and becomes the main market for pheromone dispensers. But the implication of that, it means the farmers get used to it, start to think about pheromones, start to asking, okay, well, we have pheromones for Tuta. Do we have pheromones for something else? Yes, of course. What do you use it? So the use of insecticide, the use of biorational, the use of biologicals, people start to be more open toward it. So in some way, although Tuta was very devastating, it opened the door for people to learn new tricks, new ideas, and new strategies how to manage the pest. I also mentioned in the previous 2 slides earlier, when we compared the biopesticide, we found them just as good as the synthetic one, which is, again, it's an opportunity to give the farmers an opportunity to use softer, less toxic, less harmful insecticide, which he can integrate in his strategy with the rest of the mix. Finally, natural enemies. Natural enemies are very important, very, very important, and we have to be careful and to respect them. Doesn't mean you have to buy them. They exist. They exist everywhere. Bracon is everywhere. If I go outside now, I'm pretty sure many of the entomologists in this room, if you have any, they would have noticed some bracon in many fields. Nisidicorus tenuis, it's been identified from Turkey all the way to Oman and Yemen, so it must be here. These natural enemies can do the job for you without paying them any salary. But look after them. Don't kill them and expect them to do the job at the same time. So part of your strategy need to be considering the natural enemy, cultivating them, supporting them, leave them to live happily with you and do the job for you. And for that, you have to be careful how to select your insecticide and how to apply them. Many countries now, they start to produce, they use this, the bottle gourd, which is قرعيات, هي من نباتات القرعيات, القرع, around the greenhouses, where the Nisidicorus tenuis loves to live there. And they will basically eat the rahiq, pollens. But at the same time, they are defense line for the greenhouses. For any Tuta absoluta try to come from outside, they will basically attack the eggs and parasitize the eggs. They could come into the greenhouse to attack the Tuta absoluta, but when you spray, they might be killed, but some of them are still outside. So you're developing what you call a bank, natural enemy bank. If you have open field, same thing. If you grow it around the open field, it becomes a bank for natural enemies. As I said before, our biggest battle is the farmer. We need to win him. We need to win his trust. He needs to believe in what we're saying, and we have to make sure we don't tell him fibs. If we don't know anything about it, we have to be honest and say, look, we are just as ignorant as you are, but let's work together and find the solution together. And in many cases, believe me, I learned a lot from the farmers, because this is their livelihood, this is their family livelihood, and they know how to look after it. And we learned a lot from them. And half of what I'm saying to you today is I learned it from interacting with farmers from different parts of the North African and Middle East coast. Finally, over the last 6 years actually, I was looking after this website, which is Tuta, which is basically people sending information, sending reports, sending questions, publishing papers about what's happening in the field of Tuta absoluta. And we had a good response, and over the last 6 years, we had about, until last week I checked, it was 337,000 visitors over the last 6 years. So that wasn't too bad. And I hope it will be a good forum for people to exchange concerns and results and ideas. At the end of the day, we have to learn from each other. Thank you very much indeed, and I hope this talk was not too long for you. Thank you.